Welcome to PicoGenius.com, where science, electronics, and microcontrollers come together. Today we're going to talk about aircraft instruments. In particular, we're going to talk about the altimeter. The altimeter in an airplane tells you how high the airplane is above sea level. But for it to be accurate, it has to be calibrated based on the local barometric pressure. The way we do that is we contact a organization like ATIS or online organization that will give us an accurate barometric pressure for our local area. Then we just dial that barometric pressure in with the knob here on the lower left of the altimeter. And you can see the barometric pressure in this little window, which is referred to as a Kunzelman's window. We're going to make we're going to use a microcontroller and some components to make a digital version of the altimeter, complete with barometric pressure setting. So this is the BME 280 altimeter. As you can see, it consists of a microcontroller, RP2040, which is a Pico Pi variant, a little barometric pressure sensor called the BME 280, and a OLED display for displaying both the altitude in the altimeter, and also when we set the barometric pressure, we can toggle that and set the barometric pressure and see that in the window as well. You'll notice there's a potentiometer here. This potentiometer is used to set the barometric pressure, and we do that by toggling this altitude calibrate switch that puts us in the calibrate mode, and then we have a coarse and a fine adjustment switch, and with the coarse adjustment we adjust the digits to the left of the decimal point, and with the fine adjust we adjust the digits to the right of the decimal point. We just hold these down and we turn the pressure adjustment, and it adjusts the barometric pressure. This is the schematic for the BME 280 altimeter, and as you can see, the three components. There's your processor, in the pressure sensor, and your display. These devices and the switches and the potentiometer are all connected to various GPIO pins on the microcontroller. And we're going to look at those GPIO assignments when we look at the program. The BME 280 sensor consists of a small sensor that measures barometric pressure, and in addition there's a little temperature sensor on board. And the reason we need the temperature sensor is because this pressure sensor is sensitive to temperature variations. So when we read the pressure, we also have to read the temperature so that we can compensate the pressure for a given temperature. As you can see, the board is easy to hook up. You just connect your plus supply to the processor voltage output, and one line goes to a ground, and then all the communication to the board is done over I2C serial. So here's the program that runs the BME 280. The first thing you see are a bunch of library imports. These imports are used to do things like set up the I2C communications, set up the analog to digital conversion, and then there's like 3 libraries here that allow you to generate larger fonts on the OLED display. And then, of course, there is the driver that allows you to talk to the OLED display over the I2C serial protocol. So first in the program, we initialize the I2C connection for the BME 280 atmospheric pressure, and we set the barometric pressure to 29.92. That's standard barometric pressure, and that will change when we get the information from ATIS to set to the local pressure. We also initialize the I2C connection for the OLED display, and then we go ahead and clear the display. So we also have to define the analog input for the variable resistor that sets the barometric pressure, and that's on pin 28 of the RP2040. As we said, this variable resistor allows the user to set the barometric pressure to the local barometric pressure. Next, we define the switches that allow coarse and fine adjustment of the barometric pressure. And then we have to set our debounce time for the switches to ensure that when we push the switches that they don't bounce and cause false triggers. Next, we define the switch that selects between altitude and the pressure adjust display modes. We initialize the mode to display altitude first and initialize the debounce timer to keep false triggers from happening on those switches. So there are several functions used by the main routine. The pressure sensor on the BME 280 is temperature dependent. So this first function compensates the pressure as the temperature varies. The second function handles the switching between the altitude display and the pressure adjustment modes. We use a debounce technique to prevent unintended switch bounces, and we use an interrupt on the toggle switch to trigger this function. The adjust pressure function reads the analog value from the variable resistor and maps it to the barometric pressure range. It then applies either a coarse or a fine adjustment based on which switch is pressed, updating, and it updates the barometric pressure at that time. The font underscore writer creates an instance of the writer class from the writer module. Its purpose is to enable text rendering on the OLED display using the Free Sans 20 font, which gives larger characters. This is the main program, and each iteration of the loop starts by reading the temperature and pressure from the BME 280 sensor. The raw pressure is compensated for temperature using the temperature pressure compensation function. If the program is in the altitude mode, it calculates the altitude from the current barometric pressure and the compensated pressure reading, and then it converts it to feet. It then displays the calculated altitude on the OLED and refreshes that every second. If the program is in the pressure adjustment mode, the adjust pressure function is used to adjust the barometric variable, and that's based on the analog input in the switches. The OLED shows the current barometric pressure value, allowing the user to view changes in real time as they adjust the variable resistor and press the adjustment switches. The loop ends with a sleep 1 delay to limit the display's refresh rate to about once per second. Let's go from here to a live demonstration. First thing we'll do is we'll listen to ATIS to get our barometric pressure.
Tucson Airport Information Hotel 00530, wind 080 at 7, visibility 10, sky clear below 12,000, temperature 23, dew point -09er, altimeter 3015. Visual approach.
As you heard from the report, the barometric pressure is 30.16, You can see that our altitude right now at this minute is 2521. So we're going to set the barometric pressure to adjust for local conditions. So the first thing we do is we push the switch that puts us in the pressure setting mode. I'm going to push the high digit control. That puts us at 30. And now I'm going to push the small digit control, and I'm going to adjust it for a reading of 16. There's 20, there's 16, 17, 18. It's very sensitive. Let's see what I can do here. There's 18, there's 16. And then I'm going to go back to the altimeter setting. And now we're at 2760. So now this is our true altitude at this location. The next thing I'm going to do is I'm going to take you to an elevator. And we're going to get on the elevator and see how the altitude on our barometer changes. So we're at the elevator. As you can see, we'll check our altitude. It is 2761, and we'll go ahead and get on the elevator and see if it measures our trip up. And here we are inside the elevator, as you can see. We'll go ahead and look at our, so 2758. I'm going to push the button and we'll see what the reading is. Okay, we're going up. 2762, 2765, 2775. And you notice the door is open on the second floor. We'll go ahead and push the button and take our trip down. $27.75, 66, 64, and back down to 57. So as you can see, the altimeter is measuring the trip on the elevator, and I'm sure it'll do just as well in the aircraft. I hope you've enjoyed this build project on the BME 280 altimeter. As you can see, the altimeter is pretty steady and fairly accurate. If you're interested in building this project, you can get all of the files that you need, the code, the PowerPoint, and the rest of the information you need at www.picogenius.com. Until next time, have a good day.